The next type of problem that we're going to look at are what's affectionately called sharing a job. Another way to think about this is you got two individuals who are mowing a lawn. One guy can do it in 10 hours, the other guy can do it in 12. How long would it take if they worked together? Affectionately why it's called sharing a job. Now, in this particular one, let's kind of read it and then we'll kind of clarify some things. Because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening the spillway A lowers the level by this amount in 4 hours, whereas opening spillway B does it in 6. How long will it take to lower the water level by a foot if both spillways are opened? Okay, so one way to kind of look at this is ask yourself how long would it take them to do it in an hour and kind of work backwards from there. So we'll set aside, there's A, there's B, and there is together. Okay, so if A can do the job in 4 hours, what fraction of the job can A do by itself? That would be a fourth. And if B can do it in 6, what fraction can it do in an hour? And that would be a sixth. And so together, that would be 1 over x. That would be the unknown amount. And so that's just a good old-fashioned equation then at that point. So 1/4 plus 1/6 equals 1 over x. At this point, we need a common denominator. So if I take, let's see, 6 and 4, 12, both work with 12. So if I multiply the 1/4 by 3 over 3 and the 1/6 by 2 over 2, I get 3/12 plus 2/12 equals 1 over x. And then if I add those two together, I get 5/12 equals 1 over x. Now at this point you can cross multiply and then divide, or just recognize that if we reciprocal this, we get 12/5 equals x over 1, and of course divide by 1, you're just left with x. So working together, these two spillways can empty in 12/5 of an hour, which is 2 hours and 2 2/5 is basically what that is. So I'll just kind of write that out. So 12/5 of an hour to get it done together. The next type we're going to address are sort of a physics topic, distance equals rate times time. Let me kind of write out this formula. Distance equals rate times time. Now, we're actually familiar with this. We're familiar with the rate equals distance over time. So if you think about driving a car, if you're going 50 miles per hour is a rate. The miles part is your distance. The time part, or the hour part, is your time. And if I wanted to, I could write it in terms of time, right? Time would be, if you think about how to manipulate these variables, that would be distance over rate. So even though we have one equation, there's 3 different ways that we can express that particular equation. Okay, so let's take a look at a nice simple example of this. We've got a motorboat or a boat that's traveling upstream in 10 hours, travels the same distance downstream in 7. The water's moving at a constant rate of 2 miles per hour. What is the speed of the boat? Okay, so let's identify a couple of characteristics. We've got up versus down, and we have the distance, we have the rate, and we have the time. So what do we know for sure? I know that the boat's traveling upstream in 10 hours, and I know it goes downstream in 7. Now, the boat's moving at a set speed. We're sort of making this assumption that it's if it's going 50 miles per hour, it's stuck at 50. And that water is either speeding it up or it's slowing it down. So going upstream, think if it's going against the current, would that make it slower or faster? That actually would make it slower, which is why it seems to have the problem of taking 10 hours instead of 7. Whereas if I'm going downstream, I would expect it to go faster. And in either case, it's traveling the same distance. Okay, so looking at our 3 different equations, it looks like I've got enough that I can deal with that first form of the equation, distance equals rate times time, whereas the upstream's got to equal the downstream because the boat's moving the same speed. So in that case, it would be 10 times x minus 2 has got to be equal to 7 times x plus 2. All right, so in this case, I would distribute both sides. So 10x minus 20 equals 7x plus 14. Let's see, I would add 20 and subtract 7x. And that would give me 3x on one side and 34 on the other. And so if I divide by 3, I get 34 thirds miles per hour. So the boat is moving at 34 thirds, which is 11 and a third miles per hour, if anyone's counting. So 34 thirds is a completely fine answer. All right, so in the next problem that we're going to look at, this also fits under the distance equals rate times time window, but I want you to understand why it's a different, it's going to look similar at a point, but it's not going to be as quick to solve for the missing answer, but I want you to understand why. Okay, so in this example with the boat, we were told that the distance up and down was the same. So the distance was a constant for either, and we had to figure out what the rate of the boat is. Okay, let's take a look at this question. A jet flew from New York to LA at a distance of 4,200 kilometers. The speed for the return trip was 100 kilometers faster than the outbound speed. If the total time took 13 hours, what was the jet speed from New York to LA? Okay, so let's set up, let's see, we got New York to LA and LA to New York. We have distance, we have rate, and we have time. Okay, so the distance here is 4,200 kilometers both way. The rate, okay, so this is kind of like water. You're flying up, you're flying back. One direction the wind is going to help you, one direction it's going to hurt you. So let's actually go to, well, let's see. Do we know which is which? We don't, actually. There's sort of the problem. Let's see. I know the speed for the return trip was 100 kilometers faster than the outbound. So I know that there's return. So whatever the speed of the plane is, this is going x plus 100, and that's going x. Do I know how long it took in either case? I don't, but I know that the total time was 13 hours. Okay, so let me kind of go back up here. We'll come back and address this, but I want you to point out that what the problem is here. Up here, I knew the exact amount of time that each leg of the trip went. Distance was the same, rate had that same feel, but here I knew the total time, so I had this nice easy way to set up the equation. The problem here is I don't have a way to separate the time. I know total it was 13, but I don't have the individual times that was able to get done. So instead of setting up an equation where up here I was able to set up an equation where I set the distance from the left equal to the distance from the right, I don't have that ability here because I'm missing this key component of information. But what I can do is I can write an expression for time, and then I can add the two expressions up and set that equal to 13. Okay, so I need a form of time that based on distance and rate. Let me go all the way up here. So I need a form of time that has distance and rate in it, and there it is. It's distance divided by rate. So my distance, 4,200 over x, would be the time it took to go from New York to LA, and this is 4,200 over x plus 100. Okay, so again, let me make sure we understand why this isn't working out the same as before. Because my time, I don't have the exact numbers, and I have to find a way to add these two expressions together. So now here, I can say, well, then my equation for this would be the time one way plus the time the other way adds up to 13. And that's actually an equation that we know how to solve. We've had a lot of experience solving equations, and so that's something we can go ahead and do. But I want you to understand, hopefully we catch why it's a very subtle difference. Even though the information is set up in a very similar way, the way I solve this equation is going to be a lot different than the way I solve this one. Okay. All right. So from here, I need a common denominator of sorts. Well, if I take the 4,200 over x, and I multiply that by x plus 100, plus the 4,200 over x plus 100, and I multiply that by over x, I can generate a common denominator. And so that's 4,200 times x plus 100 plus 4,200x, and all of this is over x times x plus 100 equals 13. Okay, so we're gonna do a little cross multiply action here. So we're gonna put that over 1, and then I'm gonna multiply the 13 by those two quantities. See if I got room here. Okay, so 4,200x plus 100 plus 4,200x equals 13 times x plus 100. Okay, that's a good thing we got those calculators handy, right? So then we're going to distribute. I can distribute that in there. So this is 4,200x plus 4,200 with two more zeros at it. So what, 4,200,000, is that right? Nope, I got too many zeros. I got extra zeros. Okay, 4,200 with two more. Okay, 420,000, that sounds about right. Plus 4,200x equals, well, this is 13x times x, so that's 13x squared. And that's 13x times 100, so that's 1,300x. Okay, how are we doing so far? If you want to take a break, pause the video. I'm going to keep going. I see like terms over here. And let me kind of scoot this over a little bit. Make sure I don't go off screen here. All right, so that's 8,400x plus 420,000 equals 13x squared plus 1,300x. Okay, and this thing's, well, unfortunately it's quadratic. I don't really have a way to avoid the quadratic component of it. So this is a quadratic equation. So I'm going to go ahead and move over the 8,400x and the 420 from both sides. I'm about to go off screen here so you guys can't see what I'm doing. 420 Okay, so that leaves me with 0 equals 13x squared. 1300 minus 8400 is minus 7100x minus 420,000. Okay, now at this point we have to make a decision about how, I know you're probably thinking, we're not done yet? No. We have to make a decision about how we want to proceed. So it's quadratic. The process is, if it's factorable, try it. Which, yeah, good luck with that. I will tell you it is factorable, so if you want to play with it, you're more than welcome to get there. So generally speaking, if we can't see it, then it's a good idea just to hit quadratic formula with it. All right, so since quadratic formula seems to be about the best idea we can think of, we're just going to identify our components. So A would be 13, B would be negative 7100, and C would be, yes, negative 420,000. So in setting up our formula then, I just want to make sure those numbers are not on screen yet. Okay. So it's x equals negative b. So negative 7100. Wow, I just keep adding zeros. Plus or minus the square root of b squared minus 4ac. All over to a. Well, 2 times 13 is 26. That's neat, nice. Okay, so again, I would have a calculator really close. All right, so that's 7100. So the minus give us a plus. And I'm just going to type this in my calculator. 7100 squared minus, well, if you think about it, the minus and the minus means that part's going to be plus. So whatever I get for 7100 squared, I'm going to add that to 4 times 13 times 420,000. Okay, and I get this really huge number, 7225 with 4 zeros at the end. Again, I just liked adding zeros all over 26. Yay for 26. Okay, now I'm going to go ahead and use my calculator again to take the square root of that, and I actually get a very pretty number, which is very surprising. Mathematically, that means if we'd have spent the time, we could have factored this thing. So we end up getting 8,500. Now, in context of the problem, even though it says plus minus there, if I subtract that off, I would end up with a negative number, right? And since we're talking about the speed of a plane, it doesn't make sense to have a negative speed. It's not, I don't know, is it flying backwards, I guess? It doesn't make sense in context of that. So we're going to ignore the negative part and just worry about the 7,100 plus 8,500. So let me write that out. So 7,100 plus 8,500 all over 26. And we end up with this lovely number of 600. Okay, so way back over here, go back up top here. What was the jet speed from New York to LA? That was the 600 miles per hour. Okay, so notice, and this is something you got to be careful about, you tweak the information a little bit And that adds a lot more complexity to the problem, and you'll see stuff like this, so please don't get too upset about that. Here they gave us the time, here they didn't, and they gave us the total. When they give you the total, it's going to be this process. Now, part of the reason why this was unpleasant is the numbers were really large. If the numbers were smaller, maybe we'd have a lot happier time with it, and we could have seen that it was factorable from the beginning. But because we had to apply quadratic formula, that also made this unpleasant. But it is manageable if we just be aware of that. So anyways, hopefully that helped on that concept.